Welcome to 3DOptix Tutorials. In a previous video, we went over analysis features, and now we will expand on this by exploring the individual analysis window in 3DOptix. We will go back into the file originally created for the analysis tutorial, so we have a foundation to start at. Okay, let's start by going up to the analysis portal. We'll click on this, expand the detector, and we will run the analysis. Okay, great. Now that our analysis is finished, we will click on one of the analyses, and this will pop up an analysis window into the 3D layout. Let's expand this out a little bit. Okay, let's start looking at this window. We'll start at the bottom here. The first parameter we see is pixels, 1000 by 1000 width and height. The size of the detector in millimeters, 50.8 by 50.8. Now these two parameters are the parameters we set here in the analysis portal in the beginning. We also have the total hits, or the total number of light rays that hit the detector, and the total power. Now this total power should match up in most instances with our light source that we specified. So let's go ahead and minimize the analysis portal, go to the outliner bar and click on our light source, go over to the right ribbon bar to light source settings. Okay, great, and it looks like our power is 100 watts, and we're getting roughly 100 watts on the detector. That's a good check. Go over here and maximize the analysis portal. Now, the next thing we want to calculate is what our pixel pitch or pixel size is. Okay, and to calculate this, we'll just divide the physical size of the detector by how many pixels there are. All right, let's try to do that correctly. 50.8 divided by 1000. Okay, so it looks like every pixel is 50.8 by 50.8 microns. This is good to calculate if you're trying to prototype an actual camera or detector and you know the pixel pitch. Okay, let's close that out. The last item at the bottom is the 3 bars icon, and if we click on this, we see we get the option to download our image here as an image or as the raw data. And the last two options, we can choose the view either linear or logarithmic. Linear is the default, and we can choose logarithmic if we want. Let's go back to linear. Okay, great. Now let's go back to the top of the analysis window, and we'll start with the lock icon. Okay, the lock button is toggled on and off both in the analysis portal down here and in our analysis window. So as you can see, if we turn the lock on, we'll also turn the lock on for the proper analysis in the analysis portal. Okay, and so what this is going to do, it will lock the analysis window. So if we go down here and click Run Analysis, this window will not update. All right, the next three options are just visual options, so we can zoom in, zoom out, and then if we want, reset the view to the standard view. The option to the right is wavelengths, the lambda icon, and from here we can choose which wavelengths we want to see displayed on the image. So we can choose one, a few, all, or none, as you saw there. So this is a sub option to the light source setting over here, in that we can choose which wavelengths we want to display in our image. And this comes from our light source over here. So if our light source was monochromatic, we would only have one light source over here. But this one is polychromatic, so we can see we have a few different options. And the nice feature about this is it updates dynamically. We don't have to go down and rerun the analysis. Okay. Now, one nice feature for the image here is if we click on it, we can get a cross-sectional view. Now, this updates, again, as usual, dynamically, so we can click anywhere in the image, and it'll display that cross-sectional view. All right, back to the toolbar button. Now, if we click the last option, we get a display type. We can choose a false color or grayscale image. And again, we can use that cross-sectional view over here that we clicked on to pop up last time. But what we want to look at now is the spectral view. Okay, so the spectral view will give you a view of the spectrum that is hitting your light source. And if we go back to wavelengths, again, we can choose any permutation of wavelengths that we want to display. There's our green. And we can do all or none. Now, the lowest wavelength or the smallest wavelength will be displayed over the others in this view. Now, this is a great view if you have an aberrated system and you want to see how each individual wavelength is propagating onto the image plane or the final detector. But since we only have a light source and detector, they will all look the same. Okay, and lastly, just like the XY cross section, if we put our cursor anywhere in the image, at the bottom right down here, which goes away when I move my cursor out, you will see that we can look at the actual pixel number and the value that it has displayed. This value is in intensity, and as you can move it around, you can see different intensity values. Okay, so that is a more in-depth look at the analysis window expanded from the analysis portal, and I hope this helps you utilize the analysis features better in 3DOptix.